Okay, today's notes are over 6.3, elimination with multiplication. We went over elimination last class period. In the elimination method, a variable is eliminated when you add the two equations together, only if there are matching terms with opposite signs. What do we do if we have terms that are not opposites, like 2x plus y equals 8 and 4x plus 3y equals 18? There is a method for dealing with this kind of situation. You can multiply one or both of the equations by a number of your choice to every term in order to create opposite terms. So if I look at my x terms, if I add those together, they're not going to equal 0. And if I make one of them negative, they're not going to equal 0. And the same thing with my y terms. They're not going to add up to equal 0 even if I change one of the signs. So in this case, we are going to have to use multiplication in order to make one of the equations have the same coefficients. In this case, it's going to be easier to multiply the top equation by 3. However, if you'll notice that these are both positive, and in order for the two equations to add up to equal 0, one has to be positive, one has to be a negative. So what we're going to do is we're going to multiply all the terms by -3. So we're going to distribute -3 into 2x plus y equals 8, and we get -6 minus 3y equals -24. We're not changing the bottom equation. We're going to keep it the same. So it's going to stay 4x plus 3y equals 18. Now we're ready to add the two equations together, and that's going to cancel out my y values. That's going to leave me with the -2x equals -6, and then we divide by -2, and we get x is equal to 3. So now that we found x is equal to -3, we can go back and finish solving the usual way to find the other variable. Okay, that would be to go back to the two equations and pick one to substitute in 3. I'm going to pick the top equation. It's going to be 2 times 3 plus y equals 8. That's going to give me 6 plus y equals 8. Subtract 6 from both sides. Y equals 2. So that means our solution for this system of equations is going to be 3, 2. That means those two lines are going to cross each other at 0.32. Remember, our solution is the point of intersection. Okay, I'm going to zoom in for solve the following problems using the elimination method with multiplying. So I'm going to come down to example 1, and I'm going to determine which equation to multiply. I think I'm going to go with my x's here because it would be really easy to make the x's into 4. And I'm going to put that down a little bit, make it a little thinner. Now, if I add 4 and 4, that's going to equal 8, so I need to make that negative as well. So now I'm going to multiply by -4. The point of multiplying by -4 is so I can eliminate the x's when I'm done multiplying. I'm going to rewrite the top equation multiplied by -4. That's going to be -4x minus 12y equals -40. I'm going to keep the same bottom equation. I'm just going to rewrite it. 4x plus 2y equals 20. And now I'm ready to add the two equations together. We multiply because we want one of the variables to cancel out, and the 4's, the x's, cancel out, equals 0. I get -10 equals -20. Forgot my y, so put that in there. -10y equals -20. Divide by -10, and my y is equal to 2. So I have my part of my solution. Now I need to go back and find x. I'm going to use the first equation because x is already by itself. So x plus 3 times 2 equals 10. That gives me x plus 6 equals 10. Subtract 6, and x is equal to 4. There's the other part of my solution. So these two lines intersect at 0.42, and 42 is our final answer. Number 2, I'm going to look at my variables. I've got 4 and 2 here, and I've got 1 and 5 here. To me, it would be easier to multiply the 1 and 5 to equal each other. So that means I'm going to multiply the top equation by 5. And want to check my signs. They're already opposite, so I don't have to multiply by a negative here. I'm going to go ahead and distribute 5. So that means I'm going to have 20x minus 5y, and that equals 195. And I'm going to rewrite my second equation. 2x plus 5y equals 25. I'm ready to add my two equations together because I know my y's are going to cancel out. So that gives me 20 plus 2x is 22x equals 220. I'm going to divide by 22. And my x-coordinate equals 10. Now I'm going to go back and find my y-coordinate. I'm going to plug it back into the top equation again because this is y by itself. So I get 4 times 10 minus y equals 39. Multiply that out. 40 minus y equals 39. I'm going to subtract 40 from both sides. I get negative y equals negative 1. Then I'm going to divide by negative 1. And my y equals positive 1. So these two lines, they are going to intersect at the point 10, 1. So number 2, the solution is going to be 10, 1. Number 3, let me see if I can fix that real quick. And let me just tab that over. Number 3, I have a 7x and a 4x, an 8y, and a negative 9y. Okay, this is going to be one of those situations where you're going to have to multiply both equations by a number. I'm going to pick 8 and negative 9 because they're already opposite signs. What I want to look at here is the largest number that they have in common, called the least common multiple. We've worked on least common multiple in previous grade levels. Okay, so the least common multiple of 8 and 9 is 72. So that means I need to multiply the top equation by 9 and the bottom equation by 8. Now I'm going to distribute 9 through, so I get 63x plus 72y equals negative 81. Now I'm going to distribute 8 into the second equation. I get 32x minus 72y, and that's going to equal 176. Now I'm ready to add my two equations together because I know my y's are going to cancel out. And I get 95x equals 95. I'm going to divide both sides by 95. And my x is going to equal 1. So my x-coordinate is going to equal 1, and I need to go back and find my y. I'm going to use my first equation because my y is positive. You can pick either equation you want. It should come out to the same y-coordinate. So 7 times 1 plus 8y equals negative 9. 7 plus 8y equals negative 9. I'm going to subtract 7 from both sides. I get 8y is equal to negative 16. I'm going to divide by 8, and y equals negative 2. So the solution to this system is going to be the point 1, negative 2. That is where both of these lines are going to cross each other. Okay, number 4. I have 5 and 3, 4 and 6. I think I'm going to go with my x's and cancel my x's out. The least common multiple between 5 and 3 is 15. So that means I need to multiply the top equation by 3 and the bottom equation by 5. I want to double check my signs. They're both positive. That means I need to make one of them negative. It doesn't matter which one. It's up to you. I'm going to make my 3 negative. As long as one of them's the opposite sign, we should be okay. I'm going to distribute negative 3. I get negative 15x minus 12y equals positive 42, and 15x plus 30y equals 30. Now I'm ready to add my equations because I know my x's are going to cancel out. That leaves me 18y equals 72. I'm going to divide by 18, and y is going to equal 4. So my y coordinate of my solution is 4. And I'm going to move on to find x, and I'm just going to go back to that first original equation. 5x plus 4 times 4 equals negative 14. 5x plus 16 equals negative 14. Subtract 16 from both sides. We get 5x is equal to negative 30. Divide by 5. And x is equal to negative 6. So the solution to this system is going to be the point negative 6, 4. This is the point where these two lines are going to cross and intersect. Okay, page 2. I'm going to go ahead and zoom out. Okay, unusual outcomes from the elimination method. Usually when we're doing the elimination method, at the adding step, one of the two variables drops out and is eliminated, and we're left with one variable that we can solve. However, there are two other outcomes that sometimes occur, and we've already seen that in our graph. So this is what it's going to look like when we're solving it with the elimination method. Both variables, situation 1, both variables drop out and you're left with a false equation. Watch what happens when we solve the system below. Okay, so at this point, hey, these are going to add up to 0. Yay, let's go ahead and do that. Well, that adds up to 0. Uh-oh, 3 minus 3 adds up to 0. So I get 0 on this side. And that equals, when I add those together, 14. Okay? Well, that is a false statement, okay? So we know it's false. And what does that mean for us in our system? What solution do we write? Well, if it's false, that means there's no solution. There's no answer. Okay, remember when we graphed what happened when we had no solution? That's right. It means the lines are parallel. Okay? What does that tell us about the graph of the system? That means the lines are parallel, because parallel lines do not touch and do not intersect. So they're not ever going to have a point in common. Situation number 2. What happens when both variables drop out and you're left with a true equation? So what happens when we solve this equation? And it says, oops, first we need to find opposites. Well, if I look at my x's, I just need to multiply the top equation by 2. So if I multiply by 2, I get 4x minus 10y equals negative 14. And the bottom equation would stay the same. Negative 4x plus 10y equals positive 14. So now I'm ready to add them together. And my x's cancel out, which is what we wanted. But now my y's cancel out again too. So both of them are canceling out, leaving me with 0. Well, when I get to my constant, 14 minus 14 also equals 0. So now everything cancels out, and I get 0 equal to 0. Well, that's still a true statement. 0 is equal to 0. So what does that mean for our solution? Well, that means our solution is infinite. We have an infinite number of solutions. Well, if you'll remember on our graphs, the only way that we had an infinite number of solutions meant that our lines are coinciding. Coinciding. That means it was one line right on top of the other. So we had coinciding lines when we have an infinite number of solutions. So let's try a few of these on your own. Okay. Solve the following problems. Watch for unusual outcomes. Okay, so I'm going to take a look at the first set of variables, and I see I can multiply the bottom equation by 2, and that will help cancel out my variables. So I'm going to rewrite my first one. 4x minus 6y equals 16. And I'm going to multiply the bottom one by 2. So I get negative 4x plus 6y equals negative 16. Now I'm going to add them together. That cancels out and gives me 0. That cancels out and gives me 0. So I'm left with 0 on the left side. And this cancels out and gives me 0. Well, that means it's true. And when it's true, my solution is infinite. I have an infinite number of solutions. That meant it was those coinciding lines. Number 6. I've got 5 minus 5, so when I add them together, those are going to equal 0. Well, that cancels out to equal 0. My y's cancel out to equal 0, so I get 0 on the left side. And 7 minus 12 is negative 5. Okay, well that's false. 0 doesn't equal negative 5. Well, that tells us that we have no solution. That means the lines are parallel. Okay, so you should get an x variable, a y variable, and if they both cancel out, you're going to have one of these two special cases.